This is Loyola Marymount University's innovation video, and we're going to be talking about our shell and vortex generators. So starting off, our shell, the nose is made of expanded polystyrene, and the top is made of L200 film. Both were chosen specifically for different reasons I'll touch on in a second. And then here we have kind of a top coating, which is made of Lexon polycarbonate, which will also be inserted here, which is currently in process of being made. So the reason that we chose these materials is really for that humanitarian concern and really looking at applying it to a worldwide stage. So expanded polystyrene is really common in packaging. You can find that worldwide, as well as L200 is very common in furniture or even footwear padding. So you can get both really easily, as well as that Lexon. It's fairly common. It's common in a lot of places in like basic car windshields or car parts, which again you can find around the world. The shape of it was actually specifically designed for aerodynamics. We actually verified that using computational fluid dynamics as well as physical testing, so that it's meant to kind of pass the air over the top and move it out of the way instead of just having it hitting the thing. We actually started with an iterative process to get to the final shape. We started with a fiberglass model, and then after doing fiberglass, we realized it's really difficult to shape on your own without expertise, as well as the health hazards. It's actually a carcinogen, so we didn't want to deal with that. Hence, we chose the new materials, kind of redesigned it to the shape, which actually ended up helping the aerodynamics. And then finally, we ended up with this final shape during production, which is fairly close to original model. So like I mentioned, it actually was designed specifically for aerodynamics. So we lowered the drag coefficient from 0.743 down to 0.174. So that's a huge reduction in drag, which is really helpful to really help the rider put out more power output and not be worried about wind resistance. And then the way we created was a three-step process. First, by heat shaping the L200, then applying wood glue, and then finally adding plastic dip and paint as kind of a weathering coating to make sure it's safe from the elements. And then the other part is up here. We have vortex generators. Vortex generators are used to create vortices at a separation layer. So we'd have a separation layer where the air would go up instead of down. So where that separation layer is, we put these little blue things. These are our vortex generators. They're meant to create vortices, and it mixes the air well. And actually utilize 3D printing, which is a really cool process. It's really up and coming in the engineering field, so it's cool to be applying that. And it was created here at LMU. But the shape is really easily replicated by any other process. So again, you can really use it in any other setting as well. So that's just a little bit about the innovation techniques that we designed.